Thank you.
Yeah. Ladies and gentlemen, the second session, we would like to invite Mr. Teguh Prasetya, MSG. He has currently held the position as the President Director of PT Alita Praya Mitra, provider of the end-to-end network solution for telecommunication, broadcasting, government, and corporate sector, as well as smart solution, which is designed in line with the Internet of Things, the innovative platform for automation market. Selamat siang Pak Teguh Prasetya, apa kabar?
Selamat siang Pak Satrio.
Ya, sehat dan sukses Pak.
Alhamdulillah, survive Pak, survive.
Survive ya, dan kondisi yang sulit ini ya. Ya, from the session, I think will be also interesting ya, because we learned from the first session that there are many questions come from all over the world ya. So before continuing this session, I would like to introduce Pak Teguh first. Mr. Teguh Prasetya was held the strategic position in several corporations in the ICT sector, such as CIO of PT TRG Investama, founder and president director of PT Indonesian Cloud, founder director of sales and marketing, director of business planning and development, as well as board of commissioner PT Indosat M2. He was also the strategic position as senior vice president, group head, brand marketing and value added service, PT Indosat. Mr. Teguh Prasetya was graduated from Telecommunication Engineering, Faculty of Electrical Engineering, Institut Teknologi 10 November, Surabaya. He was also graduated from Telecommunication Management, Faculty of Engineering, Electrical Engineering, Universitas Indonesia. Mr. Teguh Prasetya is actively contributed his expertise and experience in several associations and forums, such as there is many associations, yeah. ASIOT, Asosiasi IoT Indonesia, founder and chairman. Abjatel, Asosiasi Penyedia Jasa Operasional Indonesia, founder and chairman. Mastel, Masyarakat Telematika, head of IoT, EI, and Big Data, Triota ya. Kadin, KDIM, Digicop, Koperasi Digital, founder and head of devices. Ikatan Alumni Institut Teknologi 10 November, as a vice chairman. Kadin Indonesia, Indonesia Chamber and Commerce, as a member. Asosiasi Internet Indonesia, APJI, as a member. Apnatel, Asosiasi Kontrak Indonesia, as a member. Indonesia IoT Forum, founder. Indonesia Cloud Forum, as a founder. So many association. Dan kami menunggu Pak Teguh untuk bergabung di IEEE ya Pak ya. Terima kasih sebelumnya.
Amin.
Ya, terima kasih Pak Teguh. So Pak Teguh will be presenting about the development of IoT satellite, and about 45 minutes from now, the time is yours.
Okay, thank you for quite nice introduction, Pak Satrio, and also good morning, everybody, all the speaker, Pak Anggoro, Pak Denny previously, also all seniors that is here, Pak Arifin is here, also Pak Edi, and so on. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera for all of us, and very good morning. So stay healthy, stay safe. That is the new term of this new normal during this pandemic. I will share my screen, hopefully. Okay. Did everybody getting the full screen now?
Yes.
Okay.
Yeah,
So
yes.
yeah, it's full screen, yeah?
Yeah.
Okay, so first of all, before I'm starting to present, there is a video that I can play, and everybody should be enjoy this one.
You are an innovator. You're in the business of making new discoveries, going further, being the first, and doing more. Your business is global, and you have assets in some of the most remote places around the world. You need to securely communicate with those assets, whether they are in the furthest ocean, highest mountain, or deepest desert. You need a way to reliably monitor and maintain your assets, whether they are a flock of sheep, a series of weather stations, a life-saving vaccine, or a fleet of vehicles. You need low latency, low power consumption, two-way communications, machine to machine, device to device. You need Astrocast, designed by the makers of the Swiss Cube, the world's longest-lasting nanosatellite. The Astrocast nanosatellite network is designed specifically for your business. Astrocast's low Earth orbit network lets your assets call home from anywhere in the world at an affordable price. Today, more than 90% of the world remains without connectivity. Astrocast helps you bring your innovations to the entire world. With Astrocast, your business is truly global.
So there is one sample of IoT satellite that currently in place and in orbit and operating right now. So as of reference, we knew that, as I mentioned by Danny before, refer to ITU Y2060, there are 4 layers of IoT frameworks. But again, if we are referring to the latest update, actually there are 10 layers of framework, of reference framework that we can refer to. Start from the bottom, it is the endpoint. So IoT endpoint itself, it is consists of sensors or devices. Can be wearable, can be HMD, can be individual sensors, can be sensor that is located inside the connected car, can be also sensor that is inside the smart meter, gas meter, water meter, electricity meters. Also some sensor that is embedded into our consumer device, can be refrigerator, washing machine, and so on and so forth. That is the first layer. The second layer is gateway itself. The gateway is consists of protocol gateway, can be field gateway, or even edge computing gateway. The third layer, now we talk about the connectivity itself. Can be personal network, Bluetooth, RFID, NFC, can be also the local area networks such as Wi-Fi, or even wide area network, for example, wireless, Cat M1, NB-IoT, or even non-cellular one, 640, LoRaWAN, and so on. And also connectivity can be also wired network as well as satellite for connectivity. So now we talk about satellite. There is the most recent development. Actually, you are watching also on the previous video is about LEO or nano satellite. The fourth layer above connectivity is connection management. Connection management, device management, even SIM management, identity management, also another networking that is required on top of the basic connectivity. The fifth layer is about intelligent enablement. which is consists of data storage, analytic, artificial intelligence, machine learning, also the blockchain itself. So it's becoming like a platform of the connectivity and another component. The sixth layer is actually application enablement, which is consists of API gateway enabler, UI security, web application, mobile application, also the visualization. The seventh layer is about IoT user interface, which is the device that is user use, smartphone, tablet, desktop, laptop, or even wearable or HMD devices. So the layer number 8 is the user itself. Can be the internal user, can be admin, can be end user, also support customer care of the IoT itself. And it's becoming, the next one is about the ninth layer. The ninth layer is solution or service provider. Can be IoT solution owner, can be connectivity provider, or independent service providers. And the 10 is about the industry itself, IoT industry and solution. Can be smart city provider or government or local area government, healthcare provider, agriculture sectors, manufacturing sectors, transport sectors, and also utility sectors. So that is the layer number 10 of this reference network. Again, this 10 layer of reference framework is not complete without the solution provider, without the security provider, without the standardization, without the best practice that is given to the field, and also certification is required of that one, the value chains of those provider, and most important is the ecosystem that can be built up on top of everything. So this is a framework of the IoT reference. That is consists also the connectivity part, which is that we are talking and discuss today regarding the satellite connectivity. What is about the market itself? We know that main value proposition for this IoT satellite is low cost, number one. Number two is low energy consumption. Number three is global coverage. Number four is secure and high availability. Number five is dedicated network. Number six is high reliability. Number seven is enough data speed. Can be not only small, but also not even broadband, but enough. And then the last one is about non-real-time or near real-time application that is required, that one. As we are based on study that is coming from IoT UK on 2017, is mentioning that on 2022, most of the use of IoT satellite by vertical industry mainly is used by agriculture, transportation, oil and gas, utilities, also civil government. So this is 5 out of 10 that is dominate the usage of IoT satellite. The market itself, if you see here, it is also dominated by L-band of the usage, and then followed by Ku-band and C-band, also high HTS, high throughput satellite. What about the market itself? For Asia and Pacific, the market for 2023 predicted will be 292.4 million of US dollars. For sure, Leo constellation is getting the most attractive for IoT satellite currently. The market landscape itself from the satellite providers that is growing in 2021, based on the study from Nuco Group, it consists of satellite manufacture, launching and delivery, Earth observation remote sensing, upstream providers, IoT satellite provider, space infrastructure, and also downstream communication. As you know, here it is about 7 to 8 IoT satellite provider that we will discuss later on. Regarding the main value proposition of IoT satellite, for sure, regarding the lowest cost, since we think and we need IoT communication can be coped for massive quantity of user, billion of user globally. On the lowest energy consumption and footprint, device lifetime will be autonomous, will stand more than 6 years on the field. So it's just like deploy and forget. For the global availability, or we can call IoT everywhere, expected to reach more than billion of devices around the world in 2023. Regarding the secure and high availability data services should be trusted, also protected data privacy that is flowing on the network itself. Dedicated network with cognitive intelligent machine learning capabilities is required to support that. Again, continuing integration of the IoT satellite with overall communication mix for robust IoT solution is also needed for deployment of IoT satellite. High-level service reliability for the effective IoT deployment is including low latency of the L-band services that hold distinct advantage over several connectivities such as remote asset monitoring for the IoT solution itself. Higher data speed is also needed to support more bandwidth intensive IoT application in near real-time or even real-time data exchange for quicker decision-making process. So this is the main value proposition of IoT satellite that should be addressed. Okay, one example, as we have mentioned before, this is Astrocast, that was Switzerland-based company. Currently, it consists of 80 nano satellite network. The weight is only 5 kilograms. It is surrounding the globe. It is located on the LEO equatorial orbits, bidirectional module with capability of doing unicast and multicast. The TCO is low. The power is also low, only 0.335 watt. They are using L-band on 1 to 2 gigahertz, able to do OTA update on their devices or on the module itself. Low latency, it is less than 15 minutes because the constellation is 80, it's between satellite. It is 80 nano satellite right now. Security, they are applying multi-level IAS 256-bit encryption, also as Microsoft Azure compliant API. Customer get its own web portal and near real-time usage reporting, control lifetime of devices is up to 5 years. And this one is commercially available since January 25th of this year. The platform itself, maximum size of data is only 160 bytes. That is for maximum size that we can send. And that is asset originated that we can send. About asset terminated receiving, the maximum size of 32 bytes. So this is pretty much what we call narrow. The industry that they are targeting is maritime, environment, mining, oil and gas, connected vehicles, agriculture and livestock, and also asset monitoring. There is one example from Astrocast, which is founded in 2014. So they require 7 years to make it commercially available. Secondly is Swarm. This is US-based company. They are now actually having 81 satellites in space, but only 72 that is commercially available, and they will launch more and more up to 150 nanosatellite. The satellite itself will be very light, only 400 grams, located in the low Earth orbit. And their mechanism is store and forward. This is proprietary. The two-way communication available with 200 bytes per package size. There are also AIS 256 encryption. This company is founded in 2017 and currently commercially available and started from February 9, 2021. And right now they had almost 5 million plus data packets that sends over their swarm networks. And the cost itself was pretty low. Data transmission is only $5 per month. And those starter kit, if you see the top box, it is starter kit device cost is only around $119. And Swarm itself already obtained regulatory approach to operate in US, UK, New Zealand, Germany, Sweden, Antarctica, and over international water. This company is establishing global ground segments in United States, UK, Antarctica, and New Zealand. Their main purpose of usage is for energy, agriculture, environment, ground transportation tracking, and also maritime. So this is second satellite. The third one is US based as well, based on Palo Alto, named Skylo. They are based on NB-IoT technology satellite located in geostationary latency. They promise to get 250 millisecond, operating also in the L band, which is 1 to 2 gigahertz. Data rate is 20 kilobit per second, is higher than the previous one. Availability is 100%. And currently, they got 2 satellites, and they plan to have more and more, which is 75 satellites to cover global connection. And support millions of billion devices. They are saying that their TCO is lower compared with the LEO constellation satellite, and currently still not available for commercial, still on the POC stages. And the main target for them is for fishing, farming, logistic, railway, and for disaster recovery. So their hub is also pretty small. If you see that one, power consumption is less than 20 watt. And for the receive is only less than 5 watt. Standby is also less than 1 watt. So it is pretty power effective. The next satellite is a Luxembourg-based company called OQ Tech. They are using low Earth orbit nanosatellite and also combined with geo orbit satellite. So this one is combining LEO and GEO. They are using 5G NB-IoT air interface, start from the release 13. So this one is NB-IoT based. Still right now, the phase they are talking about is still on the preparation stages. And this one will be launched also this year. So they do what they call aggregation models between GEO and LEO. So LEO, it is deployed by them, but the partner, they're partnering with the GEO satellite as well to make the seamless connectivity. The next satellite provider is coming from Australia called Myriota. This LEO satellite, it is capable to handle 20 bytes user payload per message. The latency is 1 to 3 hours. They are using RESTful API with JSON. And this is may surprise you that they are using VHF. Actually, they are using 400 megahertz, the ISM band, to transmit. Also UHF, and also they are using VHF transmit on 156 to 165 megahertz frequency range. So the transmit power is for the VHF is around 26 to 27 dBm. For UHF is also same, 26 to 27. But for ISM is a lot of smaller, which is only 13 to 14 dBm. So Myriota unique patent technology has come more than 5 years right now, their research and development. And the world first transmission of IoT data used to their nano satellite was achieved in 2013. So this is the price of the device is around $600 US, and the communication is also pretty low. The next satellite is coming from UK and call it Lacuna, Space Lacuna, using constellation of LEO satellite. Currently, they have 5 satellites already in orbit using LoRaWAN air interface. And also they're using ISM band, which is 433 megahertz. And commercial service plan, actually they plan to go live on September 2021. So this is based on LoRaWAN protocol that they built the nanosatellite is. Right now, they are on the 2nd and 3rd series. The previous one is on the 1st series. The next IoT satellite is coming from the Netherlands. They call themselves Hyber, using, again, constellation satellite, LEO, LoRaWAN air interface, and right now they already have 4 nanosatellites in orbit. And for hyperband frequency, they're using 300 to 400 megahertz, but for downlink, they are utilizing 400 until 401 megahertz. For GPS frequency range, they are using 1.5 gigahertz. So it is only for GPS. So their target is on for the metering, hyper hilo they call, and then for the fleet tracking, they call it hyper heavy, and the service itself costs about $17 US per month. Okay, but again, there is a lot of satellite over there, but we should also consider barriers of adoption of the IoT satellite. Number one, for sure, it is about security issue. Since all user is utilizing IP infrastructure, network is hybrid, it's not only satellite, can be also wireless, mobile, fixed, and so on. And also those solution is based on cloud. So reliable solution right now are missing that would effectively patch vulnerability across different components of the entire ecosystem. So if this missing, then then it means it is a security holes over there. So we must be considered of to fill in the gap and to fill out the holes of the security concern. Secondly, is about cost prohibitive economics, because in the process of integration, the onboarding and management network is still remain expensive and inefficient, particularly at the large scale of infrastructure deployment. So this one will be also considered as how low we can go and how effective and efficient we can provide. The third barrier is actually old model of best practice, since more innovative approach to a large number of projects in certain IoT solution will create a new model for best practice in industry. And then it will becoming an excellent go-to-market strategy of the vertical market industry. So everybody is waiting, everybody is learning, everybody is need to get success story of it, to becoming another success story to be copy and paste. So the fourth aspect is actually absence of the holistic solution. What customer need is actually combination of all of those things, of global satellite network, cloud-based platform that could realize full benefit of IoT solution readiness everywhere around the globe, that shall be able to capture forward-thinking solution by combining all capabilities of device, any kind of network, and then combined with the open platform, also with specific needs application that is required by certain user. For the summary, I think we knew that market potential for IoT satellite in Asia Pacific is growing rapidly, especially for agriculture industry, transportation industry, cargo industry, oil and gas, even for civil government usage in 123, as we are mentioned before, predicted for Asia Pacific, market size will be around 292.4 million US dollar. And Indonesia, as we know, as an archipelago country, consists of 70,000 plus island, still need IoT satellite to cover 100% of the nation, especially for the unpopulated area. For populated area, it might be covered by cellular or wireless solution that is available. So 3 main technology is driving behind IoT satellite, which is LoRaWAN, 5G based, 3GPP, and also NB-IoT, also L-band utilization in the LEO, as well as geostationary orbital slot. So that is my presentation. Hopefully, if there is some question and answer, I can save it and I can answer for you. Thank you. I will stop my sharing. Back to Pak Satrio.
Okay, thank you very much, Mr. Teguh Prasetya, for the very insightful presentation. And if Pak Teguh make a presentation, always very, very interesting and interactive, I think. So now it's time to have a question and answer from the participant. However, some of the participants already asking the question through the application. I would like to choose some of the question that are directed to Pak Teguh. One question is, in case of technology adoption, whether LoRa, NB-IoT, or GSM, or other, which air interface platform is suitable or stable for Indonesian, which one are suitable for Indonesian government? Maybe Pak Teguh can answer this question.
Well, again, LoRa is also fully acceptable in terms of technology, right? And NB-IoT is also evolving right now, is growing, and it is developing fastly. As we know, 5G with the 3GPP release 15 is already implemented here. And shortly, release 16 will right now is they start doing POC, but again, next year will also be ready, meaning the 5.2G is also be here. And then release 17 will be another following years. It is also available. So again, this fast development and deployment of the technology is available, meaning that for Indonesian government, which is given, like I said before, government is always saying this is technology neutral. And this one can be used for LoRa, can be used also another technology that is available. So based on the regulatory that is now adopting technology neutrals, any kind of technology where it's feasible and viable on the market, it is acceptable for Indonesian government. That's what I said. But again, for the satellite, the most problematic is regarding the frequency. In which frequency that is this one, it is available and acceptable for Indonesian. For example, if it's L-band, maybe it's possible. But if it's on the 400 megahertz UHF, well, maybe this one is becoming problematic because you should coordinate with other country first and so on and so forth, and also the terrestrial. So those kind of things need to be considered and need to be put in place and harmonized between not only satellite, but also terrestrial, wireless, and mobile, as well as other usage. So that is my answer, Pak Satrio.
Yeah, so still there is some homework, Pak Teguh, that we have to collaborate with the entire technology available in the market, in the industry.
Sure.
Okay. So I hope this answer the question. There are some questions already in the Slido application. The second question, according to Pak Teguh, better we do by our country itself to do develop satellite constellation, or just join with foreign constellation satellite operation in practical, and also maybe in a business model. Pak Teguh? Yeah.
Thank you, Pak Satrio. Right. This one is difficult question actually. It's depend on how deep our pocket is. That's number one, and how fast we can give a solution. I mean, if there is some money, and then if there is a solution, and how we can construct it, because again, this one should be global constellation. It's not only covering Indonesia, but it should cover also all over the world, because all the applications supposed to be connected and interconnected between all satellite. So again, if we are talking about practically, that is currently is already in place and in commercial. So the pragmatic solution is supposed to be, okay, let's join and then let's equip more. For example, they don't have so many constellation satellite or nano satellite that is covering Indonesia. So we invest on that one. After that, then we are joined with those constellation. That is the most easiest one. And then, but again, if we are talking about ourselves, if we got enough capacity, enough capabilities, and also speed catch up, meaning that we can launch within next year or even 2 years, then it's also no problem if we can do it by ourselves. But it's more practical right now, since it's already a lot of solution for IoT satellite over there. Even 50% of it is already commercial, then we join with those constellations. So that is the easiest way for us.
Thank you. Very strategic answer. Thank you, Pak Teguh. Yeah. Most of the question is, I think, is very difficult to answer, but I believe Pak Teguh can answer with strategically way. Yeah. So the third question is in Bahasa, but I will translate in English. How Indonesia can become one of the main player in this technology? I mean, in the IoT and the IoT satellite technology, from the side where we can starting, and in where the technology is important, but very, very expensive. as Pak Teguh said, that depend of our pocket. Maybe Pak Teguh can answer this very difficult question as well. Thank you.
Okay, I think we can also contribute of the next stage. Yeah, the current state, the even the NB IoT base release 6.13 that is already in place. Maybe we cannot do more. LoRaWAN, we cannot do more. But for the 5G base release 17 and onward, which is not yet there, then maybe there is an opportunity for us. You know, establish the first one, our specification, and then compliance with that one, and then start building the nano satellite. Which the nano satellite is only 400, 500 grams satellite, right? Pretty small. I think colleague from Lapan is also proof that they can do it. They can launch it easily. But again, it also needs leapfrog of the technology adoption for us. Don't look backward to the old technology, just go forward for the newest technology, newest standardization. Based upon that, then we can build our own nation strength. You know, nothing is impossible, but if all of us on the same vision toward that, then we can do it for sure.
Yeah, it is very insightful answer, Pak Teguh. We just look forward and make our nation better with the same vision. Yeah, it is. I agree with you, and it is very, very insightful. Okay, there are some other questions. Indonesia has limited IoT server platform. As I know, Telkom has Antares, but it is once again limited. How to compete with Google Cloud, or let's say with Blink? It's also quite difficult question.
Well, nowadays the world is, you know, very famous term is collaboration. Sometimes we compete, sometimes we are collaborate, and then that becoming the terms of competition. Somewhere we are competition, somewhere we are cooperate. So again, it is no harm to use their platform. No harm for using AWS platform, for example. AWS is here. Their data center is also located here. Alibaba Cloud platform is also here, located in local data center. Just utilize that one. Meanwhile, our own platform should be improved, should be also enhanced, should be also capable to do what they do, you know, because we are start late. Usually if we are start late, then, you know, but again, we can fastening the learning curve, because we are just copy and adopt, something like that, right? That is things that we should bear on our mind. Just use them and adopting what they do, the best what they them with what they have to our platform, and then enhance our platform accordingly, and so on and so forth. So for me, I don't see any obstacle of the IoT platform, because all the global platform is also available here, reachable here, and mostly will be located here locally as well. So
Yeah,
on local data center, I mean.
yeah. Everything is will be possible. Yeah, everything will be possible, and depend on what we get approach to them. Yeah. Okay, Pak Teguh. And I think it is come to our last question. Yeah. The question is come from me, Pak Teguh. Yeah.
Curang tuh gak boleh.
Because I know that you are mastering in this industry. It is related to the development of the rural part of Indonesia. That I believe you are there. What is your insightful statement that how to approach Indonesia in terms of the using satellite? Because satellite is yes, we agree that it is very relatively easy to approach, However, the capacity is very limited, and the broadband, I mean, for the fiber optic broadband is also quite difficult to be implemented in terms of the interconnection. So what do you think that in the next coming years, Indonesia will be successful to integrate all of the national network communication?
Wow. It's pretty much difficult, because Indonesia has very limited resource too, limited budget too, The private sector, if you're asking private sector is always say how long it can be return on their investment thing, something like that. If it's not feasible, then it is going to the government. If you are asking government will also say, okay, this is the current budget that we can budget it, but mostly government owns cannot be enough. Then it comes into the third stage, which is private partnership. That is offered by the government, just like Palaparing is also PPP, another area is also PPP, is offering to the private in terms of the government project itself. So to fulfill the gap and to fulfill the hole that is not covered by the current operators and also government on budget, it should be offered by PPP approach, which is becoming, government a backing up project that is offered to private as well. So that is to cover all the nation of Indonesia, especially for the unpopulated area or even small populated, which is not economically feasible, but it is needed to be covered. So that is the basic answer of the communication need and communication area. But again, if we are talking about how about IoT? IoT is pretty much easier. If population there or even corporate there don't have the coverage, they can build their own coverage with using unlicensed band, which is the unlicensed band right now is still on 900 megahertz, but later this year we will and also with the government will add another frequency with it 433 megahertz as well that can be used for especially for the rural coverage area to connect to the IoT devices. So yeah. If you don't have any coverage, just build it. So as easy as that.
As easy as that, yeah. Thank you very much, Pak Teguh. Yeah. And in terms of IoT, yes, it is will be help much to the people, especially to improve the productivity for the agriculture, for the fishery, and any other sector. So I believe that you are there already have many activities in terms of the development IoT in the rural area, and hopefully you can continue this kindness activities, yeah. So people in the remote areas, you can also have benefit for the solution, yeah, the IoT solution. Okay, thank you, Pak Teguh. And now is the end of the second workshop session. Highly appreciated to Mr. Teguh Prasetya for your insightful and interesting presentation in the middle of your very busy activity, and hopefully all of this discussion will benefit to all of us. Again, thank you, Pak Teguh.
Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.